Hey, Cyberspace, Nathan Wallace coming at you from my home office. Today's topic is a technical deep dive into power system cyber attack vectors. So the reason it's important to really look at this, once you understand the different attack vectors as far as access, ways malicious actors could use to gain access to the system, once there's an understanding of that, you can then go in and kind of implement some of those protective measures to help mitigate that threat, mitigate that risk. So let's go ahead and get started. This is the hypothetical scenario. We have a control center. We have a WAN or wide area network. And then we have a substation, or this could be any remote site, substation, power plant, even a feeder circuit, right? If you say some distribution automation, this is intelligence, basically on the power line itself at the distribution system. So here we have let me go ahead and change this. Okay, yeah, we're on blue. So here's our hypothetical scenario as far as the network topology. This is what I'm calling the grid edge. So this is assets that are basically right there installed, kind of right there in the control house. So that's these assets right here. And then this is the devices and systems that would be basically inside the control center. So we have a human-machine interface, relay, IED, intelligent electronic devices in. So this could be 1, this could be 20, 50. There's the PLC, programmable logic controller, communicating RTU to the RTU remote terminal unit. And then this is a switch that's basically forming the control system, kind of the local area network for the local control system. So control system LAN is basically what we call this. So that's all this right here. So the solid line is basically a TCP, IP, or packet switching Ethernet network. Like I said, formed by this switch. And then we also have a dotted line kind of showing some serial communication. And what this allows you to do, you can do pass-through communication through the RTU directly to the IED. And then it also allows you to get information out of the serial connected devices to the RTU, protocol conversion basically, and then you can send it up to your SCADA operator. So hypothetical scenario, let me clear this off so I can go to the next page. All right, so as far as these different scenarios, the first one, we basically have a vulnerable or misconfigured firewall. So a vulnerable or misconfigured firewall slash, I gotta get that other L. Let me erase that real quick. So firewall slash VPN. So that could be this software that's basically running on top of this firewall. So this could just be a designated firewall, or it could be a firewall slash VPN, all kind of packaged up. So let's say that this is misconfigured, or if there's a new vulnerability that's discovered. So, that could be discovered via Shodan. We got our little hacker dude here. Malicious guy. He's sitting here with his laptop. And he discovers it via Shodan, and basically he now has remote access. Once he discovers it, you can do something like an Nmap scan, and then bam, he's in. So that allows him now direct access all the way through where he can communicate to any one of these devices. So a vulnerable or misconfigured firewall or VPN. Okay, so that's number one. Number two. Let's see. So compromised. Let's see. 2. We have a compromised IED. So this is intelligent electronic device. So I'm kind of grouping any one of these devices over here into this category as far as IED. And let me switch over. Copy this guy. Kind of the same scenario here, where we have a malicious actor who basically is running this command and control server. So what we call that is a C2 server. Let me kind of bring things closer. Here we go. So we call this a C2 server. And what happens is, like I said, if the IED itself is already compromised, the relay, the RTU, so let's say this switch, right? Let's say this switch was purchased on Best Buy or eBay somewhere, and there was malware installed, people didn't know about it. So what happens is, as soon as you plug this guy in, he's trying to phone home. So he's going to phone home through the firewall up to the C2 server. And, this is really kind of stresses the importance as far as, if you had any kind of intrusion detection right here, not only are you supposed to monitor ingress traffic, you're also supposed to monitor egress, so all outbound traffic. So the malicious actor, he's sitting here controlling this C2 command and control server. This guy phone home, says, oh, hey, I'm here, I'm alive, I'm talking. And then all of a sudden, bam, that kind of provides that entry point back in to the system, to the switch, where now he can send commands through the C2, bam, out to the system. So that's number 2. Number 3, let me switch back over to blue. Let's see, number 3, we have the malicious laptop. So this is a malicious laptop. So the actual engineer who, a designated engineer or technician, he's out here, doing his stuff, working. This is a malicious laptop. So whenever he plugs in, let's bring this back. Let me get my red pen. So whenever he plugs in to the network, what happens is, he's now connected. He can either connect directly to the RTU. Let's say if it's over some serial, plug it in, start talking. He could directly connect to the relay or PLC, or he plugs in to the switch, right? So this kind of stresses the importance as far as making sure the hardware that your the engineers and technicians use, as far as what they bring to the field, making sure that it's secure. So what we call this is a TCA, right, or transient cyber asset. All right, so that's number 3. The 4th mechanism is physical access. So this is PSP access. So this happens all the time. Substations get broken into. Feeder circuits, NEMA boxes, they get broken into, and people plug into them. So once again, let's say our malicious actor here has his laptop, and then he breaches basically the physical security perimeter. Maybe it's not configured properly, and then bam, the alarms never go off. And what he's allowed to do is basically plug right on in, and he can communicate with all this stuff. So PSP, physical security perimeter. The next one, so we have 1, 2, 3, 4, and let's see, 5. So 5 was actually, it's been observed, a lot of these have been observed over time, some at different scales, mass causing outages as far as a couple substations. Like I said, several of these have been observed. This one is stolen VPN credentials, or creds. And, same thing. We got our little black cat malicious guy here. So using some back office IT technique, he was able to gain access, still the VPN credentials, and he's able to go all the way right here. So he's kind of posing as that trusted user or authenticated user, stole their credentials, and he's able to authenticate and get into the system, posing, let's say, as the engineer or technician. So 1, 2, 3, 4, 5, and then we have 6. So 6, there's a lot of wireless types of technology. So this is almost like the man in the middle stuff. Let me scoot over here. 6 wireless. So you have the you could have towers, and this is my lovely drawing skills here. So different towers, so you can have microwave communication. There's also pole mount type of communications that there's antennas going through it, so you could have wireless back and forth as far as reclosers. Some distribution automation applications use wireless. So once you get in there, this is the typical man in the middle type stuff. There's the other one as far as 7. So you have field devices. So there's a lot of devices out here that, if you're familiar with like the Purdue model, that level 0, some people classify this as far as level 0. There's also sensors out here that kind of feed into these types of relays, automation equipment. And then the older versions, let's say if you have a CT, current transformer, PT, potential transformer, a lot of those, so let's go ahead and just draw it out. So let's say we got our CT comes in, and then bam, directly in there. So a lot of this, there's no intelligence. There's no intelligence installed in here. There's nothing really to hack, right? Some newer stuff actually has kind of intelligence. Let me erase this. Has actually intelligence kind of installed here at the CT or at the PT, and what happens is it's a fiber. So that's a fiber link here. So that means that there's some analog to digital conversions that happens here. So what happens if this sensor, how can you really, if the sensor is bad, how can you trust the data that's coming from it, right? So you have CTs, PTs, you got your breakers as well. A lot of intelligence there. You also have your different transformers where there may be some intelligence here. So what happens if these devices themselves, as far as the sensors in the field that are giving you the information, so this guy, let's say if you got your little malicious information as far as your breaker, and then let's say that this is your sensors and data monitoring stuff as far as your transformer, for instance. So when you're trying to look at all this data coming in, what happens if all that's malicious? Well, this IED is really only going to operate with the information that it's receiving, so it could potentially cause more harm or more damage, right? Same thing, if this status that's being looked at is sourced from this sensor right here, then this operator could be tricked into doing something that, he's not supposed to be doing. So there's different ways to do this. I actually forgot to mention wireless. We have different things like clocks, GPS clocks. So that's a big concern that's actually known quite a bit as far as in academic circles. Spoofing GPS packets, for instance. There's been some talks as far as Black Hat as well. That as a vulnerability. So let's kind of step back through these. So one, vulnerable or misconfigured firewall / VPN. So the daggum thing is sitting there, it's a paperweight, it's not even configured properly, so bam, guy gets right on in. Number 2, a compromised IED. So this is the intelligent electronic device that's installed out in the field, was compromised already, it's malicious software already running on it, so he phones home, and then bam, to some C2 command and control server, and then the malicious actor controls this and he has access back in. So once again, this is the importance as far as monitoring not only ingress but also egress traffic. So that was number 2. Number 3, malicious laptop. So a lot of times there's a such thing as the watering hole attack, where the vendor is compromised, and whenever the technician or engineer tries to go to it to install the vendor software, he's actually downloading malicious software when he thinks he's just downloading the vendor software. And then he goes and plugs into these devices and he's spreading malware or bringing malware in. So the interesting part here is, even if it's air gapped, you can still get in, right? You can still get in, even if this WAN connection wasn't here. This type of an attack, as far as a malicious laptop, transient cyber asset. You can introduce malware into the system via that. So that's 3. 4, you just breach the PSP. So break into the substation, power plant, break into the NEMA box. Let's see, that's 4. 5, stolen VPN creds. We've seen that. I think that was actually used in the Ukraine event, to where they stole the VPN credentials and they were able to gain remote access to the system. Let's see, 6, wireless, so microwave. I know that's poor polls as far as cell polls. So microwave communication, pole mount, wireless as well, and then things like GPS spoofing. And then 7, as far as the field devices themselves, you really have to trust the information coming from the sensors at that level 0 of the Purdue model, for instance. So I hope this kind of helped clears it up. This is kind of how I like to group things as far as the 7 different categories and then attack scenarios. So if you have any questions, comments, feel free to comment below or reach out. All right, thanks.